Well, good morning, everyone. I would like to welcome everyone to the second day of this symposium in celebration of Alex. What we have here, whenever I got the invitation to chair a session, I was completely overjoyed and thrilled, and I immediately wrote down a few little scientific remarks. But then I got a second notice that it was going to be held in a gymnasium. So I thought, oh, it's squash they want me to discuss Alex's prowess at squash, because we both go back 50 years playing squash. So I brought my squash racket. But now, whenever I saw this yesterday, I left my squash racket then in the car. So there we go. Okay. Okay, now can everyone hear me at the back? Okay, Lisa, can you hear me? Fantastic, okay. So what the session is today is to do with, as you can read all up there. Now, by properties, calculational properties, what do we mean by properties? I'm embracing properties as structure, interactions, and collisions. And a lot of personal remarks about Alex were made after his departure from Belfast to Harvard University here. So what I would like to give a few personal remarks on his Belfast days. In particular, Alex had already done substantial work in all of these areas by that time. It was a very exciting period in Belfast, as you do. And we'll go into the reasons for all of this. And whenever I arrived at Belfast, there was what was called the Dalgarno-Lewis method in perturbation theory. In fact, it was popularized a lot by Leonard Schiff in his book, Quantum Mechanics. And what that did was, in second order and higher perturbation theory, you have infinite summation of terms. What Alex was able to do was he replaced that infinite summation by the solution of a differential equation. In effect, he was solving the problem exactly. And the neat thing then about that was you could take an expansion of one or two terms of the solution, and that gave you a highly accurate systematic treatment. In fact, I think Michael Jemison here is going to follow up on that idea of the Dalgarno-Lewis method. And of course, Alex, in full modesty, whenever I was discussing this with him one time, he would say, well, Ray, that's just a matrix element. But he says, hey, it's a very important matrix element, first of all. But second of all, really, to my mind, it laid the foundation of all the subsequent polarized orbital treatments that we met in collision theory, the polarized orbital approach, pseudostate approaches, etc. So it was a very ingenious and neat method. Now, we have got 4 speakers today, and all the speakers, of course, as you know, are former students or postdocs of Alex. And there's one thing that hasn't been mentioned yet about Alex and his interaction with students. He's extremely loyal to all his students. In fact, his guiding hand comes up when they don't even realize it. He's back of the scenes. He's advanced people's careers enormously without them realizing it. In fact, a little anecdote from Belfast that might illustrate his behind-the-scenes nature. When I was there and Alex was there, we had an extremely extraordinary vice-chancellor called Sir Eric Ashby, who eventually he went to Cambridge University as vice-chancellor or whatever. That's the other Cambridge across the pond, Kate. He was just revered vice-chancellor because he met with the faculty, and when new faculty would come in, and some older faculty, the vice-chancellor would go along and meet each of them individually, personally. He would call them by name. He would give them some encouraging words of support to carry on the good work they've been doing. And everyone, particularly the young faculty, new faculty, were tremendously amazed at this. Oh, isn't this the best vice-chancellor we've ever seen? But of course, behind the Vice Chancellor, who always accompanied the Vice Chancellor at these occasions, was Alex Dalgarno. And as the Vice Chancellor was parading around, Alex would whisper in his ear, the next person, faculty member, and you know, he did this. So you see, while Sir Eric Ashby got a phenomenal memory, they thought he's got a phenomenal memory, it was really Alex who was behind all of this. Now, my mentor at Queen's was Sir David Bates, and there's no greater authority to in atomic and molecular physics. And about 20 years ago, that's what Sir David said about Alex. And that was 20 years ago. Since then, it's even accumulated tremendously. And the neat thing about this calculation of properties, of atomic and molecular properties, is Alex really believed that essential physics really came from calculation. The equations were fine as they were, but to calculate. And he invented some supremely ingenious methods. And now, as we all know, Alex research has involved all of this. He combined it. He just didn't do atomic and molecular physics for the heck of it or calculate for the heck of it. It was extremely focused, in fact. He was very interested in the Belfast days in aeronomy. And then when he came over here to Harvard, he went on to astrophysics and molecular astrophysics. And he's been involved with all of this stuff. And he really did develop molecular astrophysics to an astonishing degree. In fact, he was the key player in this. Now, as I said, when I entered Queen's in 1958, this was the year Alex was actually talking about this extremely important process. And it kind of characterizes sometimes our coffee discussions up in the senior common room in University Square, Derek. You remember University Square. Alex would sit there and with David Bates, and they'd discuss things like this. They would infuse both the faculty and the graduate students with great enthusiasm. Why are you doing something like this? Why are you calculating this and that? There was always a good mechanism there that we could look at, and it was an extremely stimulating time. Now, some of the highlights in atomic and molecular physics of Alex was, of course, the Arthurs and Dalgarno work. That was tremendous. In fact, that work on the rotation and excitation of molecules, and then subsequently later, the vibration rotation of molecules by neutral impact, that he essentially initiated an industry. And there's more chemical physicists in the US that have got their promotion and tenure because they applied these methods successfully right there. And he discussed atomic molecular structure, collisions of ultra-cold temperatures. In fact, all of this keeps on going today. Keeps on going today. The legacy is just is tremendous. Now, what is Alex's success? I've been trying to figure it out, but it doesn't take a rocket scientist to figure out the modus operandi. And what one actually comes through is he identifies the key process, he calculates the quantum process of primary importance. If there is no theory there, then he would go and construct the theory, invent the equations and do it. And he would then conduct rigorous investigations of all of these things that we heard about yesterday. And it is all basic atomic and molecular physics applied to all of these subjects. Now, in particular, as we heard yesterday on some of the photon-dominated regions, the PDRs, those, are weakly ionized plasmas. And I just learned last night from Graham Leister, who's here, that not only is this the anniversary of Alex's 80th birthday, but actually the word plasma, this is the 80th anniversary of the introduction of the word plasma by Langmuir back in 1928. So So there's a couple of things there. Now, so the evolution, you see he was evolving molecular astrophysics. And in fact, it took this tremendous power of atomic and molecular physics that he created, and him and his students, since coming to Harvard, did all of these things. And that's a tremendous. Most of us would find comfort and solace in just doing one fraction of one of those things and think we had a particularly spectacular career. But to combine all of those things in rigorous form, that's just a tremendous thing. Now, there's some of Alex's contributions are recognized in those books. And really, the latter book described Alex as the father of the modern molecular astrophysics. And that is so. And now, those of us down in actually Tennessee Williams country down south would really call him the Big Daddy. This is the Big Daddy. I don't know if Alex likes that or not. But I shared with you one personal observation at the beginning. And someone asked me then last night, well, what was Alex's relationship with David Bates? Because there was a fine Stirling department there in the 50s and the 60s. Well, it so happens that David Bates and Massey were there in Belfast before World War II. And then after World War II, David in 1951 came back and re-established the department at Queen's that Massey had originally set up in the 1930s. And as David told me one time, the best thing that he believes he's ever done in Belfast was to attract this young man called Alex Dalgarno from the University College London in 1952. And then between 1952 to 1958, there was just a tremendous activity. The whole area of atomic and molecular physics blossomed under Alex and David Bates's guidance. And it was just a tremendous time. And then in 58 then to 68, whenever David invited Alex, David would kind of leave him notes in the morning. He would come in the morning about 7:30 and called in to see you, Alex, but you were not here. And so actually David did that with me and did that with the rest of us. But if I had known Alex's trick then, I would have used it. Because what Alex did right whenever he got this note, he left a similar note the next day on David Bates's desk saying, I called in to see you, but unfortunately you were not here, signed Alex Dalgarno, 1:30 a.m. in the morning. And in fact, this continued. I see Neil Lane here. And Neil came when I was a faculty member at Queen's in '66, and Neil and I occupied an office. And I was working with David Bates, and David would again come in early in the morning, and I was not there. But I was there then at 8:30 and 9:30, and then David would come back, and we'd chat for about an hour in the office. And meanwhile, Neil was in there also, and Neil just liked the conversation. Then about 10:30, Alex would wander in. It was just Alex would wander in, sometimes with his tennis racket, etc., and start discussing with Neil on rotational excitation of molecular hydrogen, I think you were doing then. And of course, I was thoroughly just learning, just writing all of this good stuff up also. But it was just a tremendous time then in Belfast. And then one would wonder, I shared the first secret with you right at the beginning. I'll share then the final secret at the end here. You know, Alex has done atomic and molecular physics, atomic and molecular chemistry, geophysics, aeronomy, astrophysics, molecular astrophysics. And do you know what? He never actually took a university course in physics or chemistry. Maybe astronomy, I'm not sure of that, but certainly not in physics or chemistry. So really, Alex is a homeschooled student. He schooled himself. He just schooled himself. So with that introduction, and I'm still on time, I think we can now open up to his four previous Michael Jemison was a previous student, and the rest of the speakers today are his postdocs. And I've said all of Alex's students and postdocs are in terrific positions these days, professors, etc. And so I'm going to now open up the floor to Gordon Drake, who's going to discuss actually polarizabilities, frequency-dependent polarizabilities, and various interactions, properties, in fact, van der Waals molecules and work like this. Okay, Gordon, I'll hand it over to you.